Tamás is here from Easy Automator. Nice to see you again. By this video, I will show you and you can learn how you can create an intelligent box spiral with the Easy Automator tool. This is a very handy feature for grinding, sanding, polishing of small areas, or if you want to paint small areas or even bigger areas for sure as well, where you don't want to teach really the complete area, especially for grinding and polishing, but you really want just to define the area where you want to do the polishing job, and we will just create for you an intelligent box spiral, and with this one you can complete your grinding stuff. I will use the screen for this demonstration, and I will create here and maybe here a kind of box spiral pattern that you can have a kind of idea, imagination about how it could be used. As usual, I have my wooden plate as a frame. I not even fix it, it is just on the desk, and let's go. So as usual, I just prepared a RoboDK station here with a tool, robot tool frame and the home position. Okay, so actually we can start over with the Easy Automator. Just like with the zigzag line, we just have to create 1 point for the start point, 1 point for the end point. Then we just have to, with the third point, we will just define how big the area should be. And then with the last point, we can define the orientation. I will use the teach pen as a teach device. In this particular case, I do not have any manual tool like a spray gun where you could integrate the teach pen on a very quick and handy way. I don't use this. I will use only the teach pen itself. And we just go ahead with the start recording. As usual, we just have to go through the initial calibration, origin, X, Y, origin. Okay, the optical inaccuracy in this case is a little bit worse than 5 millimeters, so we have this warning message. And as first, I will show you, okay, we can come here. We are just defining the starting point. And we will go around, so I'm just coming to the end point of the first line. So we will do the first movement here, and then so on the screen we will define this area. If it's there or here, it doesn't matter. I'm just defining the third point. So this will create the area. So starting point, end point of the first line, and with the third point we just defined the area, and I just tried to make a very perpendicular fourth point for the orientation. Finish recording. Here you can see the automatically generated program. We do not need this. You can even delete this. We need only the targets. It works only with the targets. And in the Afterwork tool, so if you come into your start menu and use start in Afterwork tools, then this will open up our Afterwork tools after the installation. I have a couple of versions right now because of the development. I show you how it works. Normally you will have only one version on your PC. Okay, so here you can choose which kind of robot, which kind of tool, and which kind of home do you want to use. Here you can define the distance between the lines, between the spiral lines. I will raise this to 25 millimeters. You can define a prefix. You can additionally create a kind of approach. So we will not directly come here with the robot, but we will stay here 5 centimeters, so 50 millimeters. Here X, Y, and Z. X, Y, and minus 50 is the Z parameter. So we will not touch directly this point, but we will come here with the robot approximately 5 centimeters, 50 millimeters away from the surface, and then we will come with the next point to this area. So the first is the start point, second is the end point, the third is the boundary. That means this area will be created, and the P4 is for the orientation. I could have used the P1 as well. This is the same in this particular case. And once I hit execute, then you see that we are just generating these additional points. And if I double click here, then you can see that I have a problem with my home position, but right now you can see that even the robot can go through, and the screen can be polished, coated, or whichever process you want to use here. You can just simply cover this area with this spiral box. As mentioned, it helps a lot with mechanical processes, especially with grinding and polishing. I would like just to show you a practical way of the usage. I'm just deleting all these points which I created, and I will just start over with the recording. So we will just simulate some typical stuff that we have a couple of areas where we have mechanical irregularities which we want to polish away or grind away. And I just show you, so we can start over here. This was the fourth point. Then the second one is here. You can use any placeholder function like add comment, and then you can see, okay, this will be a new point. The add comment function you can add to the buttons, and then okay, and then add comment, and let me see. Okay, in this case I will use for sure for each of the functions for each the same distance, but we can vary this up. So you will see after the fourth, fifth, okay, I will just copy paste here that we have this kind of separation. So please don't mess up. We are not allowed to use the waypoints from the program. We just have to use the targets from here, but this helps us still a lot. So we see, okay, with these 4 points, we just define the first area, and this will be 1, 2, 3, and the fourth is the orientation. This one I want to have with 13 millimeters. Execute. Okay. Then the second one is from P5 to P8. So I just have to find, okay, P5 is the first one, P6 second, P7 the boundary, P8 the orientation. This one I want to have with 3 millimeters. Execute. And then here you can see, I just collapse them. This is the generated path 0, 1. This is the generated path. This was the second one. For sure, I could do this directly at the program generation. So we will need for the third spiral P9 up to P12, P9 up to P9. first, 10 is the end, 11, 12, and here this will be the 03, and we need 15 millimeters. Execute. And the last one here you can see this is already with the right naming, and the last one was from P13 up to P16. I'm just looking for this. P13 was the first one, second, area boundary and the orientation, and this one should be only with 1 millimeter. This was a small one. Here you can see. Tuck. Okay, once everything's done, we can take a look of each. Here I just forgot to rename this. So P1, P2, okay, this is an error with the configuration. So the distance of the robot is not a good one for this demonstration. P3, here you can see again the same problem, and P4. Okay, here we can see which kind of points. Okay, this one with the join. Yeah, okay, we can delete this. So I'm just removing the home position. This will be used only one time here at the very beginning. I'm just removing it from the very, okay. And then I will just merge all the programs with our tool, merge robot programs. And these programs, these 4, I want to get merged with the JHome. So I will just use the JHome as a start and end point, main program. Okay, that's great. And here then you can see that this will go through all the generated rectangles which we created. So it's so easy. Here you can see with this one how easily you can automatically define areas to grind, polish, coat and everything. The main program can be generated as a robot program. And here all the 4 are included, you can see here. And this main program you can export and load on your robot controller. I hope it helps you to understand how it should work and how easily this can help you to create fast and effective robot programs without the complete manual teaching of the device. And you can combine it with any kind of free recorded paths as well, for sure. So I hope it increases your productivity. I wish you a lot of success with these new features, and if you have any questions or remarks, then please just put them into the comments or reach us out on our website. Bye and have a great success.